welcome back. I hope you had understood our previous session. Now let us see the two other situations in which our ball is. So the second situation is, let the velocity of the object be v when it reaches point B having fallen through a distance x. So in here we have to notice this. Okay, when we were holding the ball at A, the height was small h, and now when we are considering the ball at the point B, so here the height becomes h minus x. So we will be continuing with this h minus x as the height in here. So let us see the second situation wherein we are considering the Newton's law of motion, that is v square, that is final velocity square is equals to initial velocity square plus 2 into acceleration into displacement. In here, as we had seen, the initial velocity is 0 and the distance is, in here we are considering, is x, and acceleration is equals to gravitational force. So when we apply the Newton's second law of formula, we get vb square is equals to 0 plus 2 into gx. As in here we are considering the distance is x, and as we know kinetic energy is 0. So like we had seen before, in first situation we got total energy is only equals to, it solely depends on the potential energy. So even in here the kinetic energy becomes half mvb square, where vb square is equals to 2 into gravitational force into distance, whereas kinetic energy is equals to mass into gravitational force into the distance. Therefore the potential energy becomes, if we put the value of actual value of height, that is h minus x in this situation, so the potential energy ka formula becomes mgh minus mgx. So if we put together, the total energy is equals to kinetic energy plus potential energy, and we get mgx plus mgh minus mgx, and in here mgx plus mgx and minus mgx gets cancelled out. So the total energy becomes, it solely depends on the potential energy, that is mgh, that is mass into gravitational force into height, that is nothing but the potential energy. Now let us consider the third situation in which our ball is, that is when it reaches the ground. Let the velocity of this object be vc when it reaches the ground near point C. In here the initial velocity is 0, this distance, the displacement is h, and the acceleration, as we know, it is the gravitational force. So considering the second law of motion, v square is equals to u square plus 2 into acceleration into displacement, where we are considering the third situation, the point at the point C, vc square is equals to 0 plus 2 into gravitational force into height. Therefore kinetic energy is equals to half mvc square, wherein vc square is equals to 2gh. Therefore the kinetic energy becomes mgh. The height of the object from the ground at point C is h is equals to 0, because it does not have any sort of height because it reaches the ground. So the potential energy definitely becomes 0 because height is 0. So if we multiply anything with 0 is 0. So the total energy becomes mgh. From equation 1, 2 and 3 we see that the total energy of the object is the same at the 3 points A, B and C. Thus every object has potential energy when it is at a height above the ground, and it keeps getting converted to kinetic energy as the object falls towards the ground. On reaching the ground point C, all the potential energy gets converted to kinetic energy, but at any object during the fall, the total energy remains constant. That is, total energy is equals to potential energy plus kinetic energy. Total energy at A is mgh. Total energy at B is mgh by excluding the h and x. Total energy at C is definitely mgh.